This is Physics Chapter 2, Problem 50, and it reads, a student at the top of a building of height h throws a ball A straight upward with the speed VO, and throws ball B straight downward with the same initial speed. Part A, compare the ball's accelerations, both direction and magnitude immediately after they leave her hand. Is one acceleration larger than the other, or are the magnitudes equal? So, because there are no forces acting on either of the balls yet, she just barely threw them with the same speed. They're still equal because gravity hasn't started to pull on either of them yet, and the initial speed is the same. So the magnitude, everything is the same. And then part B says, compare the final speeds of the balls as they reach ground. Is one larger than the other, or are they equal? So these are also equal, and we can prove it with the equation, the free fall equation, where velocity final squared equals velocity initial squared plus 2 times acceleration times the change in y. So for ball A, we get the velocity of A final squared equals the velocity of A initial squared plus 2, which in this case acceleration is gravity, so it's g, negative g because gravity is negative. And then our change in y would be negative h in this case because it's the building and they're moving down, so it's negative. So we get the velocity final squared of ball A is velocity initial squared plus 2gh, and then we square root those. So the velocity final squared of A is the square root of velocity initial squared plus 2gh. And so we can do the same thing for B using the same equation. We do the velocity final squared of B is velocity initial squared plus 2gh. Once we've seen after we plug in our negatives there. So we just get velocity final of B is the square root of velocity initial plus 2gh. So the velocities are the same.